All right, ladies and gentlemen, we're going to tackle the chain rule, which is one of the hardest topics in calculus to understand at first. Once you get it, though, I feel like it's a pretty solid topic that you'll feel comfortable with. So if this makes you happy, you're welcome to write this down. I find this extremely confusing, this chain rule, rule 8 here. I can go back to this. I think the only one that's useful here is this. And we can revisit that, but I think I have an easier way to describe this and how to go about this. One thing you should notice, though, is we've got composition of functions, and we're basically saying how do we take the derivative of the composition of functions. Well, let me give you kind of an example of f of x and g of x. Let's let f of x equal to cosine of x, and let's let g of x equal 4x squared. So let's let h of x, a new function, be equal to f of g of x. We certainly covered this in pre-calc. So what is f of g of x? Well, that's a composition of functions, and you might even be able to remember this as being written like this, f of g of x. And this is simply saying if I want f of g of x, I need to put g of x inside of x, wherever I see an x and f. Let me say that again. I'm going to take g of x and put it inside of f. All right, so I'm going to take g of x and put it inside of f, wherever I see an x. So my h of x is going to be equal to the cosine of 4x squared. This is absolutely a composition of functions. So how would I find h prime of x? Well, let's go ahead and let's look at what it asks us to do. Well, think of this as f of g of x, where the first thing we do is we take the derivative of the outside and we keep the inside. So I take the derivative of the outside, which is a minus sign, and I keep the inside. So that becomes 4x squared. Then what do I do next? Then I take times the derivative of the inside. Well, what's the derivative of my inside? Well, that's just 8x. And we are done. So let's go back to that last slide and see how it's explaining this process right here. This is saying if you've got f of g of x, you can think of that as this right here. You take the derivative of f, your outside function, you keep your inside function, then you multiply it by the derivative of the inside function. All right, if you like this way of writing it, you are absolutely welcome to write that down. Personally, I like this. I think the idea of saying the derivative of the outside, keep the inside, times the derivative of the inside, I like that a lot. So maybe get that down too. All right. Suppose we want to differentiate y equals 2x minus 5 to the 10th power. Well, let's actually think about what our f of x is and what our g of x is. Maybe take a second to see if you can figure it out. Well, is this true? Let's troubleshoot. If f of x equals x to the 5th and g of x is equal to 2x minus 5, is it true that we have the function h of x, which is f of g of x? Let's see if that's true. Okay, this is saying that my g of x is my inside. I'm going to put this g of x in everywhere into f where I see an x value. So that would be, oops, this should have been to the 10th. You were probably confused. So I'm taking that and I'm going to plug it in right there, and that would be 2x minus 5 to the 10th. So although it's kind of weird, Our outside function is x to the 10th, and our inside function is g of x equals 2x minus 5. And when we compose these two functions, we get this. All right, so let's find y prime. All right, y prime is going to be the derivative of our outside, if you can think of it like that, or you can think of it as the derivative of f of x. But you have to keep g of x inside. So how do we take the derivative of x to the 10th? Well, we do 10, and then it becomes to the 9th. But you're supposed to keep that in the inside, so that would be 2x minus 5. And then you're going to multiply it by the derivative of the inside, which is just going to be 2x. All right, let me show that to you again. You basically took the 10 down in front, you kept the inside function, or g of x, you subtracted 1 from here because you're taking the derivative of f, but then you multiplied by the derivative of the inside, or the derivative of g of x. And that's your answer. I promise you we're going to do tons of practice with this. Okay, about this one. Well, this is going to be g prime of x. Bring your 3/2 down, so you get 3/2. Keep your inside. And then you're going to subtract 1 from here, so we're subtracting 2 over 2, which becomes a 1/2. And don't forget, you have to take the derivative of your inside function, which is going to be an 18x. And now we are done with that problem. All right, how can we rewrite f of x here? We're going to rewrite it as 3x to the 4th minus 2x squared, all to the 1/2. So my f prime of x is going to be equal to 1/2 3x to the 4th minus 2x squared. Remember, this says just keep the inside as is. Subtract 2 over 2 from here, so that gives me a negative 1/2. And now I've got to multiply it by the derivative of the inside function, which in this case is going to be a 12x cubed minus 4x. All right, I'm going to introduce you to a new way of thinking about this, and it's a little strange, but that's kind of how I roll. I want you to think about this as a pregnant woman. And you're thinking, what the heck is she talking about? So here's my pregnant woman. And we've got a baby inside. And inside, you can kind of see it kind of looks like a baby in here, like it's a belly that's bulging. So this would be a 2 minus 3x, and this would be a pregnant woman. So you can think about the chain rule as the following. The derivative of the pregnant woman and then keep the baby inside of her times the derivative of the baby. So you're going to take the derivative of the pregnant woman, keep the baby inside, times the derivative of the baby. Well, in this case, we can think of the cosine, or 4 cosine, but let's just say cosine, as being the pregnant woman. And inside of the cosine is the 2 minus 3x. All right, so y prime is going to be equal to 4, and I'm just going to keep that 4 all the way on the outside, and I'm going to do a big bracket because it's 4 times everything that we're about to get. All right, what's the derivative of our pregnant woman? Well, that's going to be a minus sign. Keep our baby, so that's 2 minus 3x, times the derivative of the baby, which is a negative 3. And of course, that 4 has to be multiplied by all of that. And I like to use big brackets when I've already got parentheses used. All right, here are our last two practice problems. And I'm going to use that baby example. Hopefully that works for you, especially on this first one here. So I've got f prime of x equals the derivative of my pregnant woman, because she's holding that baby in her belly right there, is going to be a secant squared x. But remember, you keep your baby inside, so I'm going to keep that cosine x. And now I'm going to multiply by the derivative of my baby. Well, what's the derivative of my baby or my inside function? Well, that's going to be a negative sine x. All right, let's go ahead and let's do this last problem. So we've got g prime of x is going to equal to 9. Now, think of this as e to the parentheses negative 4x, and you can clearly see that your f of x function, or your parent or your mother, is going to be e to the x, and your g of x function is going to be your baby, or negative 4x. So what is this going to be? Well, this is going to be 9 times, well, what's the derivative of e to the x? Well, it's just e to the x. It's just e to the x, but we're supposed to keep our baby in, or we're supposed to keep that inside function in. So that's going to be e to the negative 4x. Now times the derivative of our baby. In this case, that's going to be a negative 4. Hope you guys can't hear all that. The wind is just blowing and howling like crazy today, but I know this is a difficult topic. We are going to practice this quite a bit. Please don't panic. We have plenty of days to cover this and make sure that we're solid on it. Thanks for watching. Have a joyous day.